All right, so this is the Algebra 2 quick review and trig in a Cartesian plane. And so if you remember, trig in a Cartesian plane all comes from the aspects of either an angle or a terminal point. And so we've got a terminal point listed right here, right? And so you see that terminal point, and it's got coordinates -4, 4. Therefore, the x is -4 and the y is +4. And from this, we can make a right triangle, right? We can make a reference triangle for z prime. Right, so you got a right triangle there. All right, the x value -4 is this side of the triangle. The y value +4 is that side of the triangle. And we can get z by simply using we could get r, the radius, by simply doing the Pythagorean theorem, right? So instead of c squared equals a squared plus b squared, we've got r squared equals x squared plus y squared, and so r is the square root. All right, so pretty simplistic. Just run the numbers here. So x -4 squared is 16, +4 squared is 16. And so we've got the square root of 32. Simplify that, right? 2 times 16. And when we end up with 4 times the square root of 2. All right, so our radius is 4 times the square root of 2. Okay. So now let's get to trig in a Cartesian plane. Remember, the sine of angle z equals the sine of z prime. And remember this relationship. Yes, the sine is the opposite over the hypotenuse, but we can also say in a trig Cartesian plane, it's y over r. So the sine of z is y over r. So really all we need is y and r, and we can come up with the ratio of the sine. And so what is y? 4. What is r? We just found it. 4 times the square root of 2. We'll simplify this by rationalizing the denominator. Ooh, pink, yuck. All right, so let's rationalize the denominator. And what do we end up with? The square root of 2 over 2 is the sine of angle z. Okay, and we can do this with the other trig functions as well, as long as we understand the relationship. Again, cosine of z will equal the cosine of z prime, the reference angle. And if you remember, in a Cartesian plane, the cosine is the adjacent over the hypotenuse. The adjacent side is x. So it's going to be x over r. The hypotenuse is r. And so you get x over r. You can go through the exact same thing. And this time, the only difference is we've got a negative, and for time's sake, hey, how does this thing end up? Negative square root of 2 over 2. And then tangent, of course, the exact same thing. Tangent of z is going to be the tangent of the reference angle z prime. And what is the tangent? The opposite, which is y, over the adjacent, which is x. So you don't really need the triangle. You don't really need any of that. If you know the coordinates of the terminal point, you can figure everything out. And so what do we get? 4 divided by -4. And so this thing just ends up being a -1. All right, trig in a Cartesian plane.